So here is a permutation combination. This is exercise 7.1, a recording of exercise 7.1. The first question, how many 3-digit numbers can be formed using 1, 2, 3, 4, 5, assuming that the repetition of the digits is allowed? So in that case, this can be filled in 5 different ways. This can be filled in 5 different ways. This can be filled in 5 different ways because you can have any of these which are also repeated. So in 5 ways you can either put this in 5 ways. So 5 into 5 into 5. 125 ways in which you can do this. That's repetitions is allowed. Okay, so then supposing repetitions is not allowed, this can be done in 5 ways. The available numbers are 5 different numbers. One number will go in, repetition not allowed, so this can be done in 4 ways and this can be done in 3 ways. Is 5 into 4 into 3. 5 4s are 20, 23s are 60 different ways. Okay. So you can also write this as 5p3. Okay, when I say 5p3, the npr formula is n factorial by n minus r factorial. So it's 5 factorial by 5 minus 3 factorial, which is 5 factorial by 2 factorial, which is 5 into 4 into 3 into 2 into 1. Or stop it with 2 and 2 and 2 and 2 factorial get cancelled. 5 4s are 20, 23s are 60. So then there are 2 different ways in which you can write. Okay, especially when it keeps reducing, the repetitions is not allowed, then you can use permutation formula. This formula can be used when repetition is not allowed. Otherwise, you have to think of only doing it like this, which is 5 into 5 into 5. So let's go to, this is alter. Hope you're clear. So let's go to second question. How many 3-digit even numbers? Even numbers. Okay, this can be only even number. Using 1, 2, 3, 4, 5, 6. If repeats are allowed, it can be repeated, then you have to do it like this way, repeated, so it can be even number. Especially when it's even number, this can occupy, this can be 2 or this can be 4 or this can be 6, which is only 3 different ways in which you can fill this. Either 2 can come, 4 can come or 6 can come, which is only 3 different ways. And rest of the places any number can come because repeats can be allowed. So this is 6 and 6 because 6 numbers are available. So that's the answer for this. So then there are a 3-digit number which can be even number. So even number means the options are 2, 4 and 6. So this can be done only 3 ways in the units place. Rest of the place repetition is allowed. So 6 into 6 into 3 is your answer. You can multiply and see. And this cannot be written by means of permutation formula. You have to do it only manually like this. Okay, so that's about this. Let's go to the third question. How many 4-letter codes, just underline 4-letter codes, can be formed by using first 10 letters of the alphabet? The first 10 letters are A, B, C, D, E, F, G, H, I, J. Okay, that doesn't matter. All that you know is 10 letters, and is repetitions allowed or not? If no letters can be repeated. So if no letters can be repeated, this can be done in 10 ways. This can be immediately done in 9, 8 and 7 because what comes here cannot come here, you know. So it has to be one less. So then this is the answer. You can also do it in a permutation way, which is 10p4. 10 factorial by 6 factorial. 10 minus 4 factorial. N factorial by n minus r factorial, where this is your n and this is your r. Okay, so then therefore it's 10 into 9 into 8 into 7 into 6 factorial by 6 factorial get cancelled. So just get the same answer when you multiply, and that's about it. Write your full answer. Let's go to fourth question. How many 5-digit telephone numbers? How many 5-digit telephone number can be constructed using the digits 0 to 9? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 numbers are available for you. Okay, if each number has to start with a 6, 7, so that's been fixed. And no digit appears more than once, which means 6 and 7 can never get repeated again because already it's there. So take away a 6 and a 7, you have only 8 numbers available for you, and no repeats is allowed repeated. So this is 8 ways, this can be done 7 ways, and this can be done in 6 ways, and 8 into 7 into 6 will be your answer. Okay, so then that's about the sum. Let's go to fifth question. Fifth question is, a coin is tossed 3 times and the outcomes are recorded. how many possible outcomes are there? Coin is tossed 3 times. It can be all head, it can be one head and two tail, and that can get juggled. It can be two head and one tail, and that can get juggled. And can be all tail, and there will be totally 8 outcomes. How do I know that there is a formula for outcomes? It is about in a coin there's head or tail, so that is 2. To the power how many times I'm throwing, so then 2 to the power 3 will get me 8. So the total number of outcomes can also be calculated like this. So then there are 8 outcomes, and so then a coin is tossed 3 times, the outcomes are recorded. How many outcomes? So then therefore it's 2 to the power 3. Let's go to next question, which is the 6th question. Given 5 flags of different colors, how many different signals can be generated? For each signal require the use of 2 flags, one below the other. So one below the other, you require 2 flags, 2 different colors, and so different. So then you can't repeat. So then there are 5 different colors of flags available for you, which means this can be done in 5 ways and this can be done in 4 ways, and 5 into 4 is 20 different ways in which you can generate this. It can also be written as 5p2, 5 factorial by 5 minus 2 factorial, which is 5 factorial by 3 factorial, which is 5 into 4 into 3 factorial by 3 factorial. So the answer is 20 ways. Okay, so then that's about it. Let's go to 7th question. That's all. The first exercise is over. So let's go to next exercise. Okay, I'll do some example sums also with this. I'm not doing the first exercise examples. I'm proceeding with the second exercise, example 5. Example 5 is a 5 factorial is simply 5 into 4 into 3 into 2 into 1, just multiply and write the answer. That's what 5 factorial means. A 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. The factorial can be represented like this also. This means it's 7 factorial. This means it's 5 factorial. So if they change it and ask like this, don't get confused. Don't think you don't know the answer, okay? So this is the third one, is a 7 factorial minus 5 factorial, which is 7 into 6 into 5 factorial minus 5 factorial. So what is common is a 5 factorial is common. 7 5 is 35, sums of 42 minus 1. A 5 factorial into 41. A 5 factorial simply 5 into 4 into 3 into 2 into 1 into 41, and you can write whatever the answer is. So taking it out common, writing 7 factorial is 7 into 6 into 5 factorial and a 5 factorial. So you can take 5 factorial out common and calculations become easier. So let's go to example 6. The sum is compute 7 factorial by 5 factorial. It's 7 into 6 into 5 factorial by 5 factorial. Just cancel, sum is 42, and that's the answer. Let's go to next question, which is 12 factorial by 10 factorial into 2 factorial, which is 12 into 11 into 10 factorial by 10 factorial, and a 2 factorial is 2 into 1. 1 can always be ignored. This is 6, and so 66 is the answer for this. So let's go to next question. So example 7 is an evaluate n factorial by r factorial into n minus r factorial. The moment I see this is a combination formula, NCR. So far I was doing NPR, which is n factorial by n minus r factorial. Okay, but now this is NCR. This is permutation. This means it's permutation. This means it's combination. Okay, the basic difference I'll tell you between permutation and combination. Permutation is generally the order does matter. In order matters. Order matters. For example, 12 is different from 21. 1-2 is different from 2-1. So the order does matter in a permutation. But in a combination, a 1-2 or a 2-1 is just taken as, say for example, combinations come when they talk about select 2 leaders from my class. So if I can't say that the 2 leaders from the class can be a Pranav and a Manish, or a Pranav and anybody else who comes from Newlin. Say Pranav and Newlin are the leaders. It can't be Newlin and Pranav, Pranav, Newlin. Doesn't matter, right? The order does not even matter. The 2 leaders. That's what does combination mean. where n stands for the total number of people in my class. So for example, we have 5 children, out of which I'm selecting 2 leaders. It's 5C2 combination. And so this formula is n factorial by n minus r factorial into r factorial. Okay, and then you have to divide it by another r factorial, because the results is much less when compared to permutation. Permutation, if you get 1, 2 and 2, 1, they're different. You count it as 2. Whereas here it's just Pranav and Newlin means just 1. So then combinations is always less. That shows that there is a division by r factorial that will make it even lesser. So then they've given this formula and they've said n is equal to 5 and r is equal to 2. Substituting here 5 factorial by 2 factorial into 5 minus 2 factorial, 5 factorial by 2 factorial into 3 factorial, which is 5 into 4 into 3 factorial by 3 factorial into 2. 4 2s are 8, 5 2s are 10. Okay, just writing it like that and solving it is very easy. Let's go to 8th question. If 1 by 8 factorial plus 1 by 9 factorial is x by 10 factorial, find x. So then this LCM will be 9 factorial. LCM will be 9 factorial, because whichever is bigger factorial, because this is 9 into 8 factorial, right? The 9 factorial is 9 into 8 factorial. So I keep it as the bigger number. So then whatever it is, 9 factorial is the bigger number. So 9 factorial is the bigger number. So I can keep it as 9 factorial, which means this starts with 8 into 7 into 6 into. So I should multiply this with a 9. This starts with a 9 factorial. So then on the numerator I can write 9. And this is perfect. So then it's plus 1 is equal to x by 10 factorial. Write the 10 factorial as 10 into 9 factorial, so that 9 factorial get cancelled. This itself will be 10 is equal to x by 10, so x is equal to 100. So let's go to next sum, exercise 7.2. First sum is 8 factorial. It's 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Just multiply and write the answer. A 4 factorial minus 3 factorial. As I told you, take 3 factorial out, which is common, and write it as 4 minus 1, because this is 4 into 3 factorial minus 3 factorial. So it's 3 factorial into 3. 3 factorial is 3 into 2 into 1 into 3. 3 3s are 9, 9 2s are 18. So that will be the answer for this. Let's go to next sum, which is the second question. Is 3 factorial plus 4 factorial is equal to 7 factorial. Okay, let's see. What is it? This can be written as 4 into 3 factorial plus a 3 factorial. The 3 factorial can be taken out common, 1 plus 4. A 3 factorial into 5, which is a 3 into 2 into 1 into 5. 3 2s are 6, 6 5s are 30, is definitely not equal to 7 factorial. It's a much bigger, no? 7 into 6 into 5 into 4 into 3 into 1. So then that's not true. So whatever that answer is, you have to write. Let's go to next question. Compute 8 factorial by 6 factorial into 2 factorial. The moment I see 6 and 8 factorial, I write 8 into 7 into 6 factorial by 6 factorial into 2 factorial, where I can readily cancel this. A 2 factorial is always 2, because 2 into 1 doesn't even matter. 7 4s are 28 is the answer. So let's go to next question. Next question is this. This question, which is fourth question. 1 by 6 factorial plus 1 by 7 factorial is x by 8 factorial. Let's take assume is bigger number 7 factorial, which means this is to be multiplied by 7 plus 1 is x by 8 factorial. So 8 by 7 factorial is equal to x by, write 8 factorial as 8 into 7 factorial. So 7 factorial get cancelled. X is equal to 64. So let's go to next question. Fifth question is an n factorial by n minus r factorial shows that this is the permutation formula, NPR formula. When n is equal to 6 and r is equal to 2, it's 6 factorial by 6 minus 2 factorial, which is 6 factorial by 4 factorial, which is 6 into 5 into 4 factorial by 4 factorial. The answer is 30. So let's do the second part. There n is equal to 9 and r is equal to 5 is the same method. You can continue doing this, and let's go to next exercise. The next exercise, I'll do some examples for you and then we'll proceed with. So then example 9. So I'll do example 9. Find the permutations of letters of the word ALLA, HABAD, Allahabad. Permutations of the letters of the word Allahabad When they say, which means permutation means juggling. I said 1, 2 is different from 2, 1. Basically, you have to juggle. So then how many permutations are possible means you have to juggle these. Okay, when you juggle this, first of all count this 1, 2, 3, 4, 5, 6, 7, 8, 9. So it can get juggled as 9 factorial. Okay, well, it's 9p9, which is 9 factorial by 9 minus 9 factorial, which is 9 factorial by 0 factorial, and 0 factorial is always 1, so the answer is just 9 factorial. So you can write it like this. But however, this should be divided by the L is occurring twice, so 2 factorial. A is occurring 1, 2, 3, 4 times, so 4 factorial. So whichever is repeating, L is getting repeated twice, you obviously cannot juggle that. And A is getting repeated how many times? 4 times. So you can see 1, 2, 3, 4. Obviously you cannot juggle among A's. But when you write 9 factorial, you juggled everything. You juggled all alphabets, all the 9 alphabets. So you have to divide it by unnecessary juggling that you did, like 2 factorial and 4 factorial. So 9 into 8 into 7 into 6 into 5 into 4 factorial by 2 into 4 factorial, where get cancelled. This can get cancelled with anything you want, and then multiply and write the answer for this. And you can check your answer. It has to be 3. What is the answer? 7560 should be your answer. You can multiply and see. So let's go to example 10. How many 4-digit numbers can be obtained from the digit 1 to 9? So 1, 2, 3, 4 digit. Okay, when the repetition is not allowed, okay, I'm all the more happy. 1 to 9, how many numbers are there? There are only 0 to 9 means 10. So 1 to 9 means 9 numbers are there. So just remember that when they give you 0 to 9, it's 10 numbers. 1 to 9 means it's 9 numbers. Without repetition means it's 9 ways, 8 ways, 7 ways and 6 ways. And you just have to multiply this and write when there's no repetition. You can also write it as 9p4. With regard to number, it will be only permutation. With regard to people, it will be combination. So then therefore, so you understood the basic difference also. So this example 10, just multiply and write this answer. This will be 3024. So let's go to example 11. Example 11, how many numbers lying between 100 and 1000? Between 100 and 1000 means you are not supposed to include 100 and 1000. Okay, can be formed with the digits 0, 1, 2, 3, 4, 5. So how many digits are there? 6 digits are there. 1, 2, 3, 4, 5, 6 digits are there. How many numbers lying between 100 and 1000 can be formed with these digits? If the repetitions are not allowed, good. No repetitions, okay? Repetitions are not allowed. So draw a 3-digit line, because the number has to lie between 100 and 1000, where 1000 is not included, 100 is not included. So it can start with 101 onwards till 999, correct? So what you have to do, and repetition is not allowed, so 999 is not possible, 101 is not possible. So what you have to do is the number cannot start with 0, a 3-digit number. So then this you cannot use, take it away. 1, 2, 3, 4, 5. This can be filled only in 5 different ways. You have to start from the left side, because a 3-digit number cannot start with a 0, so 5 different ways. Once a number comes in here among these numbers, that number cannot be repeated, but 0 can come from next place. So then this again, how many numbers are available? It will again be 5, then it will be 4. You understood why it's 5? Because one number from 1, 2, 3, 4, 5 would have come in the first position. I've used one number, but still for second place 0 is available for me. So it's 5 into 4, and this is the answer. I hope you understood. So it's 5 5 is 25, 25 5 is 25 4s are 100, and that should be your answer. This is the way I would do, and I hope you get it. So let's go to example 12. Find the value of n such that np5 is equal to 42 into np3, where n is greater than 4. What is np5? N factorial by n minus 5 factorial is equal to 42. So then what you do is make sure this n factorial is always written as n into n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5 factorial, so that the n minus 5 factorial denominator get cancelled. And write this 42 always as multiple of some numbers. 42 is 2, 21, 3 is 7, 7 3s are 21, 42. 2. Any other way? 2 2s are 4. 3, some 3 is 21. So is there any other way you can write 42 as 7 into 6 is 42. Okay, let me think about this sum. 42 into np3. I missed this part. 42 into np3, which is n factorial by n minus 3 factorial. Again, you know this is 42 into n factorial, n into n minus 1. You should make sure that it's cancelling with the denominator. N into n minus 1 into n minus 2 into n minus 3 factorial by n minus 3 factorial, where n minus 3 factorial get cancelled. Now, what else is getting cancelled? N minus 1, n and n minus 2 is getting cancelled. What are you left with? You're left with an n minus 3 into n minus 4 is equal to 42. I just told you can write 42 as 7 5 is 32, 7 6 or 42. You have to write one number, two successive numbers. You can write this as n minus 3 into n minus 4 is equal to 7 into 6. Compulsorily, you should not form quadratic equation unnecessarily. You should factorize this as, so that n minus 3 is equal to 7, n is equal to 10. N minus 4 is equal to 6, n is equal to 10. This is the way you should solve permutation. I hope you're clear. Don't form a quadratic equation unnecessarily. So let's go to next question. So next question is the second question, where it is np4 by n minus 1 p4 is equal to 5 by 3, where n is greater than 4. So then what do you write? N factorial by n minus 4 factorial by n minus 1 factorial by n minus 1 minus 4 factorial is equal to 5 by 3, which can be written as n factorial by n minus 4 factorial by n minus 1 factorial by n minus 5 factorial. You know, this minus 4 and minus 5 makes it minus 5. Now is equal to 5 by 3. You should be very careful. You know how I will write this as, I'll write n factorial as n into n minus 1 factorial, and I'll write this n minus 4 factorial as n minus 4 into n minus 5 factorial, so that denominator I have n minus 1 factorial, n minus 5 factorial, and I can cancel this with this because this is going to go up like that. I can cancel it. I can cancel this with this because it's going to be still in the denominator. So I'll have n by n minus 4 is equal to 5 by 3. 5n minus 20 is equal to 3n. 2n is equal to 20, n is equal to 10. So that is the way I would do the sum. Let's go to next question. So the next question is find the value of r. So let's go to example 13. They are asking for find the value of 5 into 4pr is equal to 6 into 5pr minus 1. 5 into 5, let it keep it, 4 factorial by 4 minus r factorial is equal to 6 into 5 factorial by 5 minus r plus 1 factorial, because when you subtract it will become plus 1, no? N minus r. So then they've given like this. I see the 4 factorial and the 5 factorial. I'll write 5 factorial is 5 into 4 factorial, where 4 factorial can be cancelled. Then I'll write this as, this is 5 into 1 by 4 minus r factorial is equal to 6 into 5 is also there. The 5 and 5 can readily be cancelled from the left side and right side. So this is 6 minus r factorial. You have 6 minus r factorial, subtract 1, it will be 5 minus r factorial. 5 minus r into 4 minus r factorial, so that 4 minus r factorial get cancelled. Thus you have a 6 minus r into 5 minus r is equal to 6. Never form a quadratic equation. Instead write this as 3 into 2. Equate this. 6 minus r is equal to 3. R is equal to 3. 5 minus r is equal to 2. R is equal to 3. This satisfies, and so r is equal to 3. Okay, let's go to next sum, which is example 14. How many number of 8 letter arrangements, 1, 2, 3, 4, 5, 6, 7, 8 letter arrangement, can be done using the letters of the word daughter, D-A-U-G-H-T-E-R. Using this, how many 8 letter words can be found? All vowels are occurred together. How many vowels are there? A, E, U. That's all. In this letter, A-E-I-O-U is the vowel. A-E-I-O-U is all the English letter vowels. But in this A-U, E is what is there. So that the 3 vowels are there. and all the three vowels has to be always occurring together. Consider three vowels as one vowel, like one ach, a print, or what do you call, one impression, so that it can take it all the three vowels as one vowel, which is one letter. So you're going to take all the three as one letter. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 we are considering 3 letters. Subtract 3 letters, you'll get 5. And add 1 letter, because all the subtracted 3 letters are categorized as 1 letter. So then there are 6 letters in total. So because this all the 3 vowels are going to occur together. So then I will consider it as in how many ways can I juggle it is only 6 factorial. Any repetition of words is coming? Unnecessary juggling? No. Every letter has come only once. Unlike in Allahabad where A was coming 4 times, so I had to divide it by 4 factorial. What else? So like that, any repetition is there, you have to divide. There's no repetition at all. So I would say just 6 factorial. Because the 3 vowels, I'm taking it as 1 vowel. So minus 3 plus 1 finally get me 6 letter words, which is 6 factorial. So that's what I would say for. But the thing is, this is 6 factor 6 into 5 into 4 into 3 into 2 into 1. But the 3 vowels which are occurring together, such as A, then it is U and E, in itself can get juggled among itself, no? So then I should also consider that and multiply it with a 3 factorial. Yeah, wherever it's coming, among themselves also they can be juggled. So this is the answer. You have to find the answer and write it. So let's go to next question, is the second part, where all vowels do not occur together. So here this question is about all vowels occurring together. So then what you do when they do not occur together, you find out in this DAUGHTER, what are the total possible juggling? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial is the ways in which you can juggle, or 8p8 is the way in which you can juggle. So just that's a total juggling. Minus the occurring together answer you will have. If you put that here, the total juggling minus occurring together will give you not occurring together. Not occurring together. So what is this answer? The previous question's answer is actually 4320. Just multiply and see, you'll get 4320. And this has to be subtracted from 4320. 8 factorial needs to be subtracted from 4320. Or you can just write this answer itself and take out common and solve it and see if you're getting not occurring together's answer. So then not occurring together is always total minus occurring together's answer. Not occurring together is always total minus occurring together's answer. So 15th question is, in how many ways can 4 red, 3 yellow and 2 green discs can be arranged in a row if the discs are of the same color or indistinguishable? Oh, discs of the same color can be treated as one color if the discs of the same color are indistinguishable. So then you know that how many ways and how many colors are there? 4 plus 3, 7, 7 plus 2, 9. So this can be done in 9 factorial ways, but same colors you can't juggle, right? So this 4 red, so 4 factorial, 3 yellow, so 3 factorial, and 2 green, 2 factorial. The same color juggling is not possible. You've juggled everything here. You have to ignore the same color juggling. So just divide this and get the answer. It's 1260. Okay, because you can't possibly juggle the same colors when you're taking the total juggling on the numerator. So next question is, find the number of arrangements of letters of the word independence. ENDEPENDENCE. How many arrangements of these arrangement? 1 second, hold on. So independence, find the number of arrangements of the word independence. How many of these arrangements do the word start with P? So I have to compulsorily, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would just do, total is 12. Okay, 12 letters are there. I have to start the letter only with P. So I can't choose this. The rest of the 11 only I can choose. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 I can choose, because P has been fixed here. So how many remaining numbers are left with me? 11 letters are left with me. And therefore I can juggle all the 11 letters here, which is 11 factorial. But however, I am not allowed to do similar numbers, such as similar alphabets. How many times is repeating? E is repeating 1, 2, 3, 4. So divided by 4 factorial. What else is repeating? N is getting repeated 1, 2, 3. So divided by 3 factorial. And then D is getting repeated. Oh my god. D is getting repeated 1, 2, 2 factorial. Anything else which is getting repeated? No, I think I've covered everything. So this is the answer. So then multiply all this. When you multiply, just do 11 into 10 into 9 into 8 into 7 into 6 into 5 into stop. Because you have a 4 factorial and a 4 factorial get cancelled. The 3 can be written as 3 into 2 and 2 can be written as 2 because into 1 can be ignored, and then find the answer to be 1663200. Whatever that answer you get, you can write it. Okay, so then that's about it. And let's go to next one. The second subdivision. Do all the vowels occur together? How many vowels are there? Let's mark the vowels now. I is a vowel, E is a vowel. Oh, E is a vowel, E is a vowel, E is a vowel. Any other vowel that is there? No other vowel there. How many vowels therefore? Aramark 1, 2, 3, 4, 5 vowels are there. The 5 vowels are there, out of which E only is occurring 4 times. And there's one more vowel which is I, which is occurring only once. And all these vowels are going to be occurring together. I have to treat it as a 5 letter, all the 5 letters as one letter. Like an impression, because they're going to occur together. So, but among them, the juggling, we'll think about it later. So now, how many letters are there? It's totally a 12-letter word. So then, in 12 letters, I'm going to subtract 5 letters and add 1. When I subtract 5, 12 minus 5 is 8, and add 1, it will be 9-letter word. You know, because you're treating the 5 letters as one letter. So remove a 5 and add a 1. 12 minus 5 is 12 minus 5 is 7, right? 7 plus 1, 8. Okay, I'm sorry. 12 minus 5 is 7. 7 plus 1, 8. So then therefore this becomes, if I'm going to consider all vowels to be one letter, in juggling it will be 8 factorial. Okay, so that's done. But what about this vowel itself getting juggled? But 4 of these vowels are same. Correct? So then it's E, 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 and with one I, how many juggling will be possible? This will get juggled as in how many ways? Because I can come here, all the E's can come here. I can, I can come here and E can be here. So then the I can shift its position in different ways, and I'm going to write it as, among this will be 5C1. Because I can come here, I can come here, I can come here, I can come here, and E's can get juggled like this. So it's 5C1 combination. 5C1, 5 letters, out of which 1 is I, and I'm going to write combinations of I getting shifted in this in various position, which is combination 5 factorial by 5 minus 1 factorial, which is 4 factorial, into R factorial, which is 1 factorial. This 5 into 4 factorial will get cancelled. The answer is 5. So you have to multiply this with 5. And 8 factorial multiplied with 5. And 8 factorial multiplied with 5. So then what will be and any other letters is getting repeated here? Yeah, I didn't consider the repetitions. It's 8-letter word in which D is getting repeated twice. I forgot that. I have to divide it by 2 factorial. And anything else which is getting repeated? N is getting repeated twice. So that should also be there. And D is getting repeated. N is getting repeated thrice. So you have to divide it by the repetition, which I totally forgot. So I hope you understood. So since I'm treating all the 4 E's and 1 I as one single vowel, one single letter. So then therefore it's 12 minus 5 plus 1, which will result in 12 minus 5, 7 plus 1, 8 letters. But when I juggle the 8 letters as 8 factorial, I know that N is getting repeated thrice, and then D is getting repeated twice. So that completes that, and this itself, among itself, this can be juggled. If you want, you can write it like this. This can be juggled as 5 factorial by e cannot be juggled, so divided by a 4 factorial. Instead of doing a combination of nc for 5c1, you can either do it as a combination 5c1, or you can do it as a 5 factorial in total getting juggled, and you have to ignore the 4 factorial which is e getting juggled, because juggling of e should not be taken into account. They are all of same kind. So 5 into 4 factorial by 4 factorial. So multiply this whole answer with a 5, you get the answer. The answer is 16,800. So let's go to next sum. The third sum, do the vowels never occur together. You know, total minus occurring together will give you not occurring together. So total will be, you already found what is the total from the first equation. No, first equation we fixed p, so we can't say that. Total is 12 factorial by what are the repeats. You know that e is occurring, how many times is e is occurring? 1, 2, 3, 4. So by 4 factorial, and you know d is occurring, n is occurring 3 factorial, d is occurring 2 factorial. So these are the repeats. So then we have to do it like this. In the first one I kept p fixed, so I had to do 11 factorial, but in this I can do 12 factorial. And so this is my total minus occurring together's answer will be here, because I just did occurring together answer, which is 8 factorial by 3 factorial and 2 factorial into 5. You can just solve this and get your answer for this. I hope you understood. Let's go to next question, which is the fourth question. Do the words begin with I and end with P? So in the 12 letters, the first letter has to be I, the last letter has to be P. So among the 12 letters, 2 letters are fixed, so that leaves us behind only with the 10 gaps, which can be done in 10 factorial ways, in which you have D's coming twice, whatever, how many times, you know, and you have E coming 4 times, N coming 3 times, and okay, whatever the repetitions are, you just write it, and that's your answer. Okay, so what is it? Do all the words begin with I and P. So let's go to next, which is exercise 7.3. So the first question, how many 3-digit numbers can be formed using the digits 1 to 9? 1 to 9 is like 9 letters, and no digits is repeated. When no digits is repeated, I can do it using 3 letters. 9p3 is permutation. NPR, 9 factorial by 9 minus 3 factorial is 9 into 7 into 6 factorial by 6 factorial. 9 sevens are 63. That's all. When the repetition is not allowed, then it's very easy. Or alternatively, 1 to 9 is 9 letters. This can be done in 9 ways. Okay, sorry, I forgot 8 here. Sorry. 9 into 8 into 7. So 9 into 8 into 7 into 6 factorial by 6 factorial. So right answer. Or this can be done in 9 ways, this can be done in 8 ways, this can be done in 7 ways. Multiply this, either way you get the answer. You can choose to do whichever way you want. The second question is, how many 4-digit numbers are there with no digits repeated? Again, with no repetition, 4-digit numbers. You know the number 4, there are numbers available is from 0 to 9, which is 10 numbers are available for you. But a 4-digit number cannot start with a 0. So, you know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I can't take a 0. So, I am left with only 9 other options, leaving a 0. This can be done in 9 ways. Repetition not allowed. So, then out of 10, 0 cannot come. So, I filled this first one with a 9. But the second one, 0 can come. So, 1 letter has come here. So, balance only 9 letters are there. This is 9 into 8 into 7. 1 reduction here. Okay. So then that multiply this and get this answer. So then let's go to next question. Is the fourth question. So is it fourth or third question? Sorry. How many 3-digit even numbers can be formed? 3-digit even numbers can be formed by using the digits 1, 2, 3, 4, 6, 7. Even numbers are 2, 4 and 6. So this can be done in 3 ways. Either 2 or 4 or 6 can come there. In all these positions, in this first 2 positions, no digit is repeated. Repetitions is not allowed. So one of the number comes here. The available number, such as 1, 2, 3, 4, 5, 6 numbers are only available for us. Okay, one of the numbers comes here. So balance only 5 numbers into 4 numbers, 5 into 4 into 3. So just multiply this and that will be your total number of ways and you can do that. Okay, so let's go to fourth question. The fourth question is normally when they do this, they will do 5p2, which is 5 into 5 factorial by 5 minus 2 factorial, and 5 into 4 into 3 factorial by 3 factorial. So either way this answer for this is a special case, you can't plug in the formula. So let's go to fourth sum. Find the number of 4-digit numbers and that can be formed using the letters 1, 2, 3, 4, 5 if no digit is repeated. How many of these are even numbers? Okay, this is the second part of the question. Let's answer the first question. So 4-digit number, this can be done without repeats. So it's 5 ways, 5 numbers are available. One number goes there, so into 4, into 3, into 2. So 5 into 4 into 3 into 2 is the total number of ways in which you can form a 4-digit number using these letters. But how many of them are even numbers? Then in the units digit you can only have a 2 and a 4, which can be done in 2 ways only. So out of this, no repeats is allowed. So one of the number has come here. The available number is not anymore 5 numbers, it's only 4 numbers. So this can be filled in 4 ways, this can be done in 3 ways, this can be done in 2 ways, 4 into 3 into 2 into 2, and write your answer. So let's go to next sum. I hope you're clear. Fifth question is from a committee of 8 persons, how many ways can you choose a chairman? So there are totally 8 persons. How many ways in which you can choose a chairman is like 8C1, just combination number of people, like choosing a leader. So then 8C1 is 8 factorial by 8 minus 1 factorial into 1 factorial. NCR is n factorial by n minus r factorial into r factorial, which is 8 into 7 factorial. So it can be done in 8 ways. The 8 people, so that can be done only in 8 ways. Okay, so let's go to next sum. Next sum is they're not only selecting a chairman, I'm sorry, they're also selecting a vice chairman, which means they're choosing a chairman and a vice chairman. It's 8C2, a combination of 2 people. I told you this is not permutation. Whether it's Pranav or Newland Pranav doesn't even matter. So it's just, but who is the chairman, who is the vice chairman? Should we think of it like that? Maybe. Okay, so then can we choose a chairman and vice chairman, assuming one person cannot hold more than one post? So let's do the sum and then figure out. According to me, it's just combination, which is 8 factorial by 8 minus 2 factorial into 2 factorial, which is combinations formula. NCR is n factorial by n minus r factorial into r factorial, which is 8 factorial by 6 factorial into 2 factorial, which is 8 into 7 into 6 factorial by 6 factorial into 2 factorial. This get cancelled, this becomes a 4, 7 4s are 28, a number of ways in which you can select 2 people out of 8 people. But my question is, would the order matter? Something I have to think about. So then I did it as a combination. I still had to multiply it with 2 because the order does matter. Whether it's Pranav, Newland, Pranav, chairman and vice chairman, 2 different posts. So it's not leaders. So I have to multiply it with 2. I could have directly done the sum as a permutation. Taken it because the order does matter in this 8p2 and I'll directly get the answer. So let's go to next question, which is the sixth question. Sixth question is n minus 1 p3 is to n p4 is 1 is to 9. N minus 1 factorial by n minus 1 minus 3 factorial is like npr formula. N factorial by n minus r factorial by is 2. So which is the n factorial by n minus 4 factorial is in the ratio 1 is to 9. So this is nothing but n minus 1 factorial by n minus 4 factorial, because n minus 1 minus 3. So then the n minus 4 factorial is getting just directly cancelled. The denominator can be written as n into n minus 1 factorial. So this also get cancelled, therefore n is equal to 9. Okay, so then next question is seventh question, where it is 5pr is equal to 2 into 6pr minus 1. Find r. 5pr is 5 factorial by 5 minus r factorial is equal to 2 into 6 factorial by 6 minus r plus 1 factorial, because when you put 6 minus r minus is common, so so this will become 5 factorial by 5 minus r factorial. is equal to 2 into 6 factorial by 7 minus r factorial. Just compare this and this. You can write it as 6 minus r into 5 minus r factorial, reducing 1. So this gets cancelled. And this can be written as 6 into 5 factorial. So that 5 factorial get cancelled. So now you have, what are you left with? 7 minus r into 6 minus r is equal to 6 2s are 12. Never write it like this. Write one number below one number successively lesser. 4 3s are 12. 7 minus r is equal to 4. R is equal to 3. 6 minus r is equal to 3. R is equal to 3. Satisfying. So r is equal to 3. So let's go to the next question. So you can do the same thing for the second subdivision. I'm not going to do that. I'm going to go for the 8th sum. How many words with or without meaning can be formed by using the letters of the word equation, E-Q-U-A-T-I-O-N, using each letter exactly once? How many, so they didn't give the number of words, so just juggle it. 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. Is there any repeats? Any alphabet is coming twice? No alphabet is coming twice, so answer is just 8 factorial. Okay, just juggle it and write it. If there is any repeats, then you have to divide it by the unnecessary juggling of the repeats. Let's go to exactly only once. Yeah, the letters themselves are exactly occurring only once, so no problem. 9th question is how many words without meaning can be made from the letters of the word Monday, M-O-N-D-A-Y. Okay, assuming that no letter is repeated, if 4 letters are used at a time. So at a time you can use only 4 letters. And how many letters are available for you? 1, 2, 3, 4, 5, 6. There are no repeats. So this can be done in 6 ways, into 5 ways, into 4 ways and 3 ways. So 6 into 5 into 4 into 3. Or you can take it as a 6P4. You can either way you get 6 factorial by 6 minus 4 factorial, which is 6 factorial by 2 factorial, which is 6 into 5 into 4 into 3 into 2 factorial by 2 factorial. Still get the same answer. So let's go to next. The second subdivision, this is first subdivision. The second subdivision, all letters are used at a time, which means all these letters, so it's 6 factorial, because you're going to juggle everything. And anyway, there's no repeats, just 6 factorial or 6P6. That's all is the answer. And all letters means obviously it will be 6-letter word, right? So third question, third subdivision, all letters are used, but the first letter is a vowel. So all letters are used, it will be 6-letter word. And the first letter, 1, 2, 3, 4, 5, 6, the first letter has to be a vowel. How many vowels are there? O and A are vowels. There are 2 vowels in total. So one of which will come here, which can be plugged in as 2 ways. So rest of the 5, there are no repeats also. So one word comes here. Out of the 6th letter, 1 letter goes here. So the balance 5, which can be done in 5 into 4 into 3 into 2 into 1 way. So just multiply all this along with the 2 and then you get the answer. So that's about it. Let's go to 10th question. Is MISSI, SSI, TPI, Mississippi. How many distinct permutations of the word Mississippi where 4 I's are not occurring together? I told you not occurring together is total minus occurring together. Occurring together and all I's have to occur together. Okay, so we are going to treat the 4 I's to be one single I, one single vowel, alphabet. Okay, so how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. From 11 you have to subtract 4 and add 1. When you subtract 11 minus 4, 1 goes here, it will be 7 plus 1, so would it make it 8? So because I'm considering all the 4 letters as one word, removing 4 and adding 1, 11 minus 4 is 7, 7 plus 1 is 8, it becomes an 8-letter word which will be 8 factorial. Where all the 4 I's have constructed as 1 I, so I'm not bothered about that repetition. But S is getting repeated 4 times, so I have to divide it by 4 factorial. P is getting repeated 2 times, so I have to divide it by a 2 factorial. I is repeating twice, 4 times, I am considering anyway it is 1 letter. That is the total minus, so that is not the total, that's actually occurring together. The total will be, how many letter words did I say? 11 factorial by everything that is occurring together. You have to same letters such as S is occurring 4 times, I is occurring 4 times, P is occurring 2 times. This is total permutation and total juggling, and this is occurring together. Both of these have to be subtracted and the answer has to be written. It's total minus occurring together. Total is 11 letter word. So 11 factorial by all the repeats repeated letter has to be divided. Those juggling is not permitted. And occurring together means the total letter becomes 8 letter. I hope you were clear. Subtract it and get the answer. So let's go to next question, which is 11th question. In the word permutation, Permutations. Okay, the how many letter word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letter word. In the 12 letter word, you're going to consider the word always starts with P and end with S. So P is fixed and S is fixed. What else is there? So there are only 10 gaps in which you can fill the rest of it. So which can be done in 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So that's all. It's basically 10 gaps and 10 numbers, 10p10. Which is 10 factorial by 10 minus 10, which is 0 factorial, which is 1, and so 10 factorial is the answer. So that's about it. When you fix P and S, you have to take those away and you have only 10 gaps and you can juggle it. And any repetitions? Okay, 1 second. I am doing it using, I have a doubt here, okay. So then look at this, I am doing it as 10. Oh, I have done it as 10 into 9 into 8 into 7. Okay, generally you just cross verify. You have 10 options, which is juggled by 10 factorial in this gap. But how many repeats themselves are there? You know, E is getting not repeated. No, forget it. What is getting repeated? A T is getting repeated twice. What else is getting repeated? Apart from T? That's all. So it's 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial, and the 2 factorial is going to get cancelled. I wrote it here 2, it shouldn't be, because 1, 2, 3, 4, 5, 6, 7, 8, 10, 9, 8, 7, 6, 5, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8. Because this is how many letter word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letter word. I'm fixing this and this. I'll have to do 10 factorial, the juggling of all this, but there are repeats. 1 second, hold on. So I'll continue the sum in the next video because my tuition has started. So I'll don't ignore the this sum. Learn only till 10th sum. This is the last sum in 7.3, which I'll continue in the next video.